right, today we're going to talk about the angle bisector theorem. And that's down on the bottom of page 313. And it says that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. If a point is on the bisector of an angle, then it is equidistant, equal distance from the sides of the angle. And a picture of that would look like if you had an angle and then you bisected that angle, and we'll make the blue line the bisector. Bisect means to split it in half, right? So if I bisect that angle with the blue line, then these two angles that I just created are congruent to each other. So this says if a point is on the bisector of an angle, it is equal distance from the sides of the angle. So that means that any point along the blue line is equal distance to the sides of the angle. So this distance would be the same as this distance. When you're measuring the distance from a point to a line, it always has to be along a perpendicular. So AC is congruent to CB. These two pieces will be equal to each other. Angle APC will be congruent to angle CPB. And P to C, that's a ray, isn't it? Okay. Ray PC is an angle bisector. Make sense? Kind of makes sense, right? That if you have the side of an angle on the top and the side of an angle on the bottom, and you draw a line right through the middle of that angle, which is the blue line, that wherever you stand or wherever you stood on this blue line, you would be the same distance from both sides of the original angle, wouldn't you? Because you're on a bisector. So you have to be the same distance away from the sides.
When having a bisector within an angle, would that always create two right angles?
It doesn't create two right angles, but the distance from any point along the bisector, if you were to measure the distance from this point D to side PB. This segment has to be perpendicular. If you were to measure from point D here to this side of the angle, that piece has to be perpendicular. Okay? So a couple of examples. And actually, let's get the other part of this theorem written down first, the converse of the angle bisector theorem. And it says, it's right below the original theorem on page 313. If a point in the interior of an angle, so if a point in the interior of an angle is equidistant or equidistant from the sides of the angle, then it is on the bisector of the angle. So that application will look very similar. All right, here's an angle. And then let's say that a point in the interior of the angle, so here's a point in the interior of the angle, is equidistant from the sides. So if we measure the distance from this point to the sides, and when we measure it, it's got to be a segment perpendicular to the sides. And if these two pieces are congruent to each other, if a point in the interior of an angle is equidistant from the sides of the angle, well then that point is on the bisector of this angle. So now we're just kind of doing everything backwards here. That point has to sit on this line. And the blue line is the angle bisector. So this is the way you'll get this question, is you'll get a picture like that, and then you'll be told something like 5z plus 23. These two smaller angles down here, and the other one is 6z plus 14. Find the measure of, let's see, t. Find the measure of t, s, u. So you know from the theorem that if this point is the same distance from both sides, it's on the angle bisector. If it's on the angle bisector, then these two angles are congruent. And if the expressions represent those angle measures, then 5z plus 23 is equal to 6z plus 14. And you can solve for z. So 23 would equal z plus 14, and subtract 14. So 9 equals z. If 9 is equal to z and they need this angle, TSU, Then you take the 9 and you substitute it for the z. So you would have 5 times 9 plus 23. So the measure of angle TSU equals 5 times 9 is plus 23, 68 degrees. What if they asked for the measure of angle? Let's put a V right here. TSV.
You would just times that by 2.
Exactly. You would multiply the 68 by 2 because these two angles are equal to each other. So what's 68 times 2?
136.
136. Very well done. So does anybody have any questions on the theorem or the converse of the theorem?
No.
Short lesson, huh?
Yeah. That's it?
Unless you want to do the next section.
No, it's okay.
No, it's fine.
Sure?
Yeah, we
Yeah.
can.
Yeah, we're fine.